Hello everyone, I'm Dr. Prajwith Rai. Today we are going to discuss about secondary hemostasis. Now we all know that whenever a vessel gets damaged, the hemostasis sets in. Now the first step in this is vasoconstriction, which can happen because of the direct injury to the muscle, which will lead to the spasm of the muscle, or the endothelium gets damaged, which will stop secreting nitric oxide, which will stop secreting prostacyclin, so the vessels will go into spasm. And also when the nociceptors are getting stimulated because of the chemicals, it will go into spasm. That is the first step. The vessel will reduce in size, less blood flow will happen. Now along with this, the primary hemostasis happen. What is primary hemostasis? The platelets will come and aggregate here and it will form a clump, but this can be washed out by the blood flow. So what we have to do it? We have to cement it with a fibrin clot. We cement the platelet plug with the fibrin clot. So we have discussed how the damaged endothelial surface will lead to exposure of the collagen, led to platelet aggregation. Similarly, the tissue factor will get exposed whenever the endothelium is damaged, and this tissue factor will activate the factor 7 and it will bind to the factor 7 and it will form a complex, and this complex will activate the factor 10. Now this pathway is called as an extrinsic pathway. Now this will activate factor 10. Now similarly, there is one more process that happens. Now after the platelet aggregation, the platelet will secrete a protein called as pyrophosphate kinase, which will form a polyphosphate chain on the surface of the platelet, which will have negative charge on it. Now, whenever there is a negative charge and there is high molecular weight kininogen which is released by the endothelium or which can be present in the plasma as such, when this negative charge is coming in contact with factor 12, along with the high molecular weight kininogen, it gets activated. Now this will activate factor 11 and the next number will be factor 10, which is already activated. So it will activate the factor 9 and factor 8. So it is 12, 11, no 10, but 9 and 8. Now this 9 and 8 will combine to form a complex, and this will again activate the factor 10. So at the end of intrinsic pathway and extrinsic pathway, what we saw is there is a factor 10 activation. Now this pathway is called as a intrinsic pathway. Now both places we have seen the activation of the factor 10. Now this factor 10 will bind to factor 5 and it will activate the factor 5. Now this factor 5 and 10 will form a complex along with calcium and the phospholipids. The phospholipids are coming from the surface of platelets. Now the platelets which are already there forming a clump. Now this phospholipids on the surface of the platelet along with calcium and factor 5 and 10 will form a complex called as prothrombinase. And what it does, it breaks the prothrombin into thrombin. Now this thrombin is active and this thrombin will lead to breaking of the fibrinogen into fibrin. Now this will break the fibrinogen into fibrin, and these fibrins will form link with each other and it will form a fibrin strand. Now it will form fibrin strands. Now these fibrin strands, the fibrin has the capacity of activating the factor 13. Now once the factor 13 gets activated, this factor 13 forms a cross-linking of these fibrin strands. Now this cross-linking of these fibrin strands will make a fibrin mesh. Now this fibrin mesh is the end product of the coagulation. Now all these factors were required for the formation of this fibrin mesh. Now we saw that platelet plug was formed as soon as there was damage to the vessel. Now once the coagulation is activated, the secondary hemostasis has started, the fibrin clot will form a mesh and cement this platelet plug which is present there and preventing from the bleeding and stabilizing the clot. Now this is what happens during the coagulation. So what did we see here? We saw there was an extrinsic pathway which was activated by the tissue factor, which binds the factor 7 and activates the factor 10. Now similarly, once the platelet is aggregated, the pyrophosphate kinase will form this polyphosphate chain, which will activate factor 12, which activates factor 11, 9, and that activates factor 8, which forms a complex with factor 8. The factor 9 and 8 complex activates factor 10. Now both this factor 10 in any pathways can activate the factor 5, which forms a complex prothrombinase activating the thrombin, which breaks the fibrinogen to fibrin, which also activates a factor 13, which is responsible for the cross-linking. Now what we saw here is the first pathway to get activated is this because of the exposing of the tissue factor. The extrinsic pathway is the first step to get activated, the fastest to get activated, but it will not be as efficient as intrinsic pathway, because intrinsic pathway will have very high amplification. A single pathway can amplify the process by 3000 times. So that's how high amplification happens in the intrinsic pathway. Whereas the extrinsic pathway, it will initiate the process, and it will, as soon as the damage is happened, this initiation is done by the extrinsic pathway. But very important to understand is that whenever the intrinsic pathway is getting activated, because it is the fastest to get activated, it will activate the factor 7 forming complex, factor 10. At the end, it will activate the factor 2, which is thrombin. Now very important to understand, this thrombin will again activate the factor 5, it will activate factor 7, it will activate factor 8, it will activate factor 9, and it will activate factor 13. What we have to understand is it has activated all these factors, that is factor 11, factor 8, factor 7, factor 5 and factor 13. Very important, you see this thrombin has activated the factor 9, which can activate factor 11, which can activate factor 9, and which can activate factor 8, and the intrinsic pathway can start by itself. It doesn't need this factor 12 to start this process. So that is very important to understand. The thrombin will initiate the intrinsic factor. So even without factor 12, we can have active intrinsic pathway. So whenever there is a vessel damage, the first step to start is the tissue factor getting exposed and extrinsic pathway activating, which in turn can activate the intrinsic pathway. Now this is about the coagulation cascade and how an intrinsic pathway activated, how an extrinsic pathway is activated, and how a common pathway is activated. And these are the various the coagulation factors that are present in the plasma, which are responsible for the coagulation. Thank you everyone. I hope you have understood. Any doubts you can put in the chat box.